I'll start back here. Just some background of the software. So the IMAC-GHG-LCCP tool, it's an updated version of the lifecycle climate performance tool for Mac systems, estimating CO2 emissions for Mac systems, both indirect and direct, developed with the IMAC-GHG-CRP group at SAE, Cooperative Research Project Group, for developing LCP systems. And now OTS has the control to continue to develop this tool and distribute it moving forward. So to review, go back to the history. Previous version was Green Mac tool, fully Excel-based tool developed in the early 2000s. Work was done on this tool to improve it over early 2000s until 2007, when the tool was made globally available. And then years later, after EPA proposed regulation for MAC credits for reducing CO2 emissions, more interest was developed in improving the MAC LCCP tool, and enhancements were proposed up until 2017, when OTS got involved with developing the tool. Work was done to improve it up until this year, when OTS is going to be continuing to develop the tool and release it to those interested. So yeah, as I mentioned, Green Mac, fully Excel-based tool, previously, the standard for evaluating LCCP of Mac systems, and used for determining alternative refrigerants to R134A, but it has it's not as user-friendly as you'd like. So there's interest in developing a new version of the tool with an improved user experience and improved calculation speed. So the new tool has a UI that more user-friendly, a bit more robust, has some error handling as well, and the calculation speed is improved significantly, from multiple hours down to a few minutes. There's also new features added to the software for Green Mac. Support for electrically driven compressors is in the process of being added. Water-based systems are supported by the software. The reporting has been improved. The grams per mile are now weighted based on percentage of vehicles in U.S. cities. Curve fits for capacity and COP are improved. And also there's an auto-saving feature to the software that saves your inputs and can those inputs can be reloaded to the software. So just to give a brief breakdown of what we're actually reporting by the software, we're reporting the life cycle climate performance in kilograms CO2 equivalent emissions, and that's made up of the direct emissions and the indirect emissions. So the direct emissions are made up of direct refrigerant leakage due to vehicle operation, vehicle service, and the end-of-life disposal of the refrigerant. Also, the atmospheric breakdown of the refrigerant is also included in direct emissions. For the indirect, this is made up of the CO2 equivalent emissions from the MAC component materials, the manufacture of those materials, the operation of the MAC system itself, and the fuel used to carry the weight of the MAC system, and then also the equipment, an assumption for the equipment used to charge the MAC system with refrigerant. So with that background, I'll switch over to the tool and give a walkthrough of the software and all of the inputs. So as of right now, the tool is essentially a exe that you can run from your Windows Explorer. And double-clicking that exe opens up this front page with the version number and some text here. So clicking enter will take you to the system selection screen. So this screen allows you to enter a project name. So there's a project file that will be saved as you inputs to the software. So you can name that project file. And then there's you select a number of systems that you'd like to evaluate simultaneously. So you can select up to 6 systems simultaneously. I'll just evaluate 1 for now. From here, you can name that system to differentiate it, and you can also select a refrigerant used for that system. So we support these 4 refrigerants: 1234YF, CO2, 152A, and 134A. And you can also use a user-defined refrigerant. The next screen shows the built-in assumptions for the refrigerant selected. So the GWP, the atmospheric breakdown products of that refrigerant, and assumptions for CO2 equivalent emissions for recycled refrigerant, for transport, and fuel consumption for that refrigerant. And then the only inputs for this screen when using a built-in refrigerant are whether the refrigerant is recycled during servicing or not, and the leakage rate of the refrigerant over its lifetime. So that's in grams of refrigerant per year. So I'll enter 10 for that. The next screen here is to select which cities you would like to evaluate this vehicle in. So you filter those cities by the region that the city is located, and then the country that the city is located, the United States. And then you have a selection of cities that are built in here. So I'll select all supported United States cities. So there are 49 United States cities supported in this software. And as you select, as you click Add Selected Cities, climate data and vehicle usage data for each city is loaded into the software from an Excel file. Also on the screen is a selection of the vehicle. So here you select the size of the vehicle, the pulley ratio of the compressor, the efficiency of the engine that affects the power consumption of the compressor, the fuel used by the system, and the transmission, which is not an input here. You can look at the assumptions for the fuel, the conversion rates from fuel used to CO2 emitted on this fuel data button screen. Also input on the screen are the leakage rates for service, professional service, and DIY service. And you can change the inputs. If you have cities from different regions, you can enter different leakage rates for each region. So next screen here is after selecting all the cities, you can modify the inputs for those cities in the UI. So inputs such as driving distance assumed in that city for a vehicle per year, the vehicle lifetime of vehicles in that city, and the percentage of vehicles that are manual AC operation versus automatic. then also you can modify the percentage of time that air conditioning is on at particular ambient temperature bands. And all of these changes will be saved to your project file. The next screen of inputs here is for the component mass inputs. So, little air conditioning system is made up of a number of different components. Each component is made up of different materials. On this screen, we're assuming that each component has a specific kilogram mass of the entire component, and then that total mass is broken down by percentage into different materials. So there are built-in assumptions for percentages for each of these materials, but these percentages can be changed. Also, because there are a large number of inputs on this screen, manual input of all of these could take some time. So we have support for loading an Excel file to load all these inputs automatically. So by default, there's a file that will work and load in all these inputs, but you can modify this file and load it in with your own values. So I'll show this template file now. So this template file mimics what's shown in the UI. You can enter a total mass of each of the components and then a percentage of that mass for each material. And it also includes some of the assumptions for the conversion rates from energy of production to CO2 equivalent emissions. And you can enter these values for up to 6 systems. So then the next screen here is for inputting power consumption of the cooling fan of the Mac system. And the power consumption is entered at a range of vehicle speeds and also ambient temperatures. And this is used as an additional power consumption to the compressor. The next screen here is to determine whether the Mac system is driven by a belt or electrically driven, like by a battery. So we'll go with belt driven for this, but for electrically driven, instead of inputting the capacity and power consumption based on compressor RPM, you would be entering it based on vehicle speed instead. So again, this screen is the capacity and power consumption of the Mac system at a range of ambient temperatures and relative humidities, and also compressor RPM speeds. So again, because of the large number of inputs, we allow for a template Excel-based loading process. So I'll pick a default value here to load in capacity and power input values. You can switch between tables by clicking this tab. We have support for multiple evaporators and chillers. So then the last screen here is the drive cycle screen. So there's support for drive cycles for each of the cities that were shown previously. And the software automatically picks the drive cycle for each city based on its location. So because we're looking at United States cities, the software automatically picked the FTP and SCO3 drive cycles. There's also support for the AC-17 drive cycle, which you can use for all USA cities by clicking this checkbox. In addition to that, there is support for a user-defined drive cycle. If you click one of these buttons, it'll ask you to add or remove particular cities that are using a particular drive cycle, if you'd like to use that. And then you can load that drive cycle from a template file. There's this engine RPM template file that can be used to load in a particular drive cycle. So I'll run calculation using the default drive cycles. Should take about a minute to run through all 49 cities. In the meantime, I can show some of these other template files, just the capacity file. So similar to the component mass input file, the capacity file mimics the user interface and allows you to enter a large number of inputs for capacity and power consumption for systems 1 through 6. But it looks like the calculation is complete. So once the calculation is complete, the results report is automatically generated. So I'll go through that now. To start, I'll talk about the name. So the name of the results file is basically the time that the project file was started, began. Your project file name, the results, and then the time that the calculation was run. So going through the results here on sheet 1, you have your cities going from left to right. So here we have the 49 cities that we evaluated going this way, and then we have the systems evaluated vertically. So only one system, so it's all right here. We have the total estimated kilograms CO2 emitted for each of these cities, and then we have the direct and indirect below that. And then below all of that, we have the contributions for refrigerant leakage, atmospheric breakdown for the direct, and then AC emissions, power consumption, the components, and fuel use and equipment. And then beyond that, we have a few charts here plotting the total kilograms CO2 emitted for each city, the annual CO2 emitted for each city, and then the CO2 emitted per kilometer for each city. After that, we have a number. We have 2 different weighted results charts. So these are just for USA cities. So the first is just for the cities, the green MAC cities. So here we have 11 cities that were previously featured in green MAC, weighted based on percent of total vehicles in the cities, in these cities. So weighted based on vehicle density. And then there's a calculation for a total weighted average of grams CO2 per mile for this vehicle and the system across all of these cities. And this value is plotted as well. And beyond that, we also have weighted output for all supported USA cities, so all 49 supported cities, weighted based on vehicle density. And these numbers come from a study done at NREL. And again, we come up with a weighted average estimated grams CO2 per mile for this vehicle. And that is plotted. So that's an overview of the inputs and the results of the system. One thing that was generated from running through that system is a project file. So after you run through a calculation, you have a results Excel file that's automatically saved into this My LCCP project and results folder, and it's named as I mentioned before. And then you also have this project file. So I named it My Project File, and this contains all of the inputs that you input to the software as you went through. So looking at this file, you start with your project name, the systems that you evaluated, details about the refrigerants used for each system, any values for the vehicle used, the fuel and the efficiencies, and then the loss during service in different regions for each system. You have the percent manual and automatic inputs and the driving distance and vehicle lifetime for each city, mass inputs for the components, fan power consumption inputs, and then the capacity inputs. So all these are saved into a single project file, which can be reloaded. So I'll do that now. So to reload a project file, on this first system selection screen, you click Load Project, and it'll open up this project folder, and then you can click My Project File. It'll load in all the inputs I showed previously. So project loading complete. So we can click OK, and all of the available inputs should be loaded in here as we click through. So the cities are selected. These inputs are the same. The component mass inputs have been entered. These values have been entered. Yeah, so all the inputs have been entered successfully, and then we can rerun, and we'll get the same result. Yep, so that should be the same. So that's basically it. That concludes my walkthrough. If there are any questions, feel free to put them into the chat of the GoToMeeting, or you can email them to lccp@thermalsystems.com. Also, feel free to email there if you have interest in trying out a demo version of the software. We're offering 30-day demonstration versions. Okay, if there are no questions, then thank you everyone for attending. And yeah, feel free to email LCCP with any more questions and any other interesting details. So one question was regarding the project file. I'll pull that up. Let's see, so the previous one. So there are certain values, certain default values that are saved into the template, the project saving template, that will come up even if you only have one system. So for the refrigerant, it only shows for a single system, but for this screen, for the vehicle screen, there are values for multiple systems, even though we're only running one. And this is just a function of how the template is set up. This is basically just showing the default values for each of these systems that show up in the UI. But that's a good note. I think we can make a note of that and in the future try to only show values that are input by the user for the system they're evaluating. Sure, and I saw there's another question for running AC-17. So that's going to look pretty similar to how we ran the other drive cycles. Basically, pulls the numbers in the background and runs through every step of the drive cycle. I can evaluate it. Actually, I can just. Thing I didn't show is the template for loading a drive cycle. So there's an Excel file here that shows the values for the different drive cycles that are built into the software. The numbers for AC-17 aren't included here, but could address that in the future if there's interest in that. But for user-defined drive cycles, there's two template spots here that you can add in your speeds and your engine RPMs for as many points as you like going down this direction, and the software will load all of these in, and then you can run these. So it needs to be entered in these four columns here. So yeah, like I mentioned before, numbers for all the drive cycles are included in these list boxes here. So the numbers in these list boxes are actually what the software uses. So these numbers can be trusted here. These are the numbers of drive cycle that are pulled by the software. So similar to AC-17, these are the numbers used by the software and the speeds. So just clicking over here uses this drive cycle for all cities. Yeah, there was may have been a bug where this checkbox wasn't working as intended, but that's since been addressed. So AC17 is supported here, and here are the results. And you could compare the results here. Okay. Any other questions? Okay. Yeah, thank you everyone for attending. Again, if you have additional questions, please send them to lccp@optimizedthermalsystems.com and we'll get back to you.